Hello, everyone. Good morning, good afternoon, good night, good evening. Welcome to 60 minutes of unscripted .NET entertainment. As doctors of .NET, we're going to be prescribing healthy choices in .NET. I'm your host, Myra Wenzel, with my co-hosts, Cam Soper and David Pine. And I would like to welcome today's guest, Jesus Angulo. He's going to be talking to us about .NET MAUI and how to declutter your view models. Do you want to introduce yourself to us, Jesus?
Yeah, thank you, Maria. Hello, folks. I'm Jesus Angulo. I am a software developer located in Peru, Lima, Peru, and I also a Microsoft MVP. I've been developing in the .NET ecosystem for a long time. So I saw Silverlight, UWP. Lastly, I've been watching Summary and .NET MAUI. So yeah. Today I'm going to share a little piece of knowledge about it.
Welcome to the show. And do we have a checkup doc for today?
We do. I will share that right now. Today's checkup doc is announcing .NET MAUI Preview 11. So it's not much of a document, it's more of an announcement. I will just very quickly scroll through it where it talks about the new features of MAUI 11, Preview 11 rather. And I gotta be honest, I don't know anything about MAUI. I'm not a UI guy. I'm much more of a back-end, kind of like web API person. But so this document talks a little bit about the new window control styling, multi-window apps, templates and C#10, and some additional miscellaneous errata. So if you are into MAUI, I would recommend you go check out the new features in .NET MAUI Preview 11, and hopefully Jesus will tell us a little bit about that today in today's hallway track. And I think that sounds like a great chance to transition.
Okay, awesome. My talk today it's about a specific topic inside this UI framework, which is .NET MAUI. In fact, .NET MAUI can use different patterns to develop the UI. One of the most famous is the MVVM pattern, which will be discussed today. But yeah, .NET MAUI allows us to use others like MVU, Code as UI. But in this case, we're talking about the MVVM because it translates to other technologies as well. If you are a WPF developer or a WinUI developer, you will probably know very well the model view model pattern.
Now, real quick question. So,
sure.
Now web developers might be familiar with MVC, Model View Controller.
Yeah, exactly.
What's MVVP or MVVM? I'm sorry.
Yeah, it's a modification based on MVC created by Microsoft when they introduced the binding capabilities in WPF, in SAML specifically, because MVC doesn't fit that well for binding rich UI components. So MVVM is a derivation based on that when we introduce the concept of the view model, where we place models or model projections of the data, and that data can be bind to the view. So that pattern is quite well for developing this kind of application, and it translated to Xamarin Forms and .NET MAUI as well. The problem with the pattern is that it just only mentioned the main components and the relationships between them, but what happens very often is that when you are working in a line of business application, for example, you end up having a very complex UI to begin with. It's not like the demos or samples that we usually look at in the internet. It's different, and the application evolves, and that adds some complexity to the view model. So the view models in some cases end up being quite large. So hard to maintain, have a lot of logic. So this talk is kind of specific because we're looking in that issue. What kind of patterns, tips, and tricks we can use to declutter, to separate, to split that logic in pieces that we can maintain, more easily change. So that's the overview
Okay.
what we're talking about. Let me share my screen if we are ready to begin with the code. Okay.
I got you.
Fasten your seatbelts. In this talk, we need to check a lot of code because let's talk about the context again. This problem only happens when you have a very complex application to begin with. So if I kind of review what we can do, we need to have a sample that is complex enough to have this problem. But if I'm going to use a real world application, that could be maybe too much of a complex to start. So I create a little sample, complex enough to have some pain points that we can take care, but simple enough to we can understand what is this app about and how it works, and we can refactor it here. Let me share my code. This sample app is quite simple. It's an exchange currency application. We have some local currency. This is the PEN, local currency here in Peru. And we are trying to buy, for example, US dollars. And they have a exchange rate for sell US dollars and for buy US dollar if you have a change in different directions. So this app is quite simple. You put the amount of money you want, for example this, and you see the change. You start this operation. You need to make sure which bank accounts are you transferring the money from, and which account you are transferring the money to, where you want to receive your money after the change. Then when you validate this, you can register your operation and you get the details about it and or account number, so you can transfer the money that you owe us, and then we can transfer the exchange money back to you. And that's the application. In this case, we're using .NET MAUI, and that can be translated to your existing Xamarin Forms applications that are in production right now. And the knowledge that we are going to discuss here could be easily translated to WPF, UWP, WinUI, etc. Anywhere where you are using the MVVM pattern. But given that we are focusing on the UI logic, we are not focusing much on how the application looks. And we are focusing more on the code and how the VM works. So let me show you around the code. Let me start with this. We have 5 patterns that we are going to discuss in this case. So let me start with the first. Yeah, go ahead.
Could you zoom in on your code just a little bit for us?
Sure. Let me go to 200. So?
Perfect.
Okay, got it. Yeah, when you have a different size monitors, it's hard to guess the right amount of zoom. Okay, this is the first view model that represents or is bind to the first screen. And we have some code, like for example, when we navigate to that screen, we need to check the API and get the latest exchange rate, for example, to show it in the screen, get some default amount to show, and calculate the amount you're going to receive. And some code that happens when you change those amounts. We need to update in 2 ways. If you change the amount you want to receive, we update the amount you have to send, and vice versa. So we have a lot of code here, but it's not like a lot of line of code because it's less than 200. But the complexity arises because it's pretty easy to make this run, for example, and nobody notice at first sight. There is no way to notice. It's some code and behavior here, and it's hard to maintain. We can make a little change there and everything stops working right. So we are focusing on the first change that we want to make, that is fixing the anemic models. That's a common pattern around other types of applications, also not only UI. If you remember, the main components in the MVVM pattern is a model, view, and view model. The first two are quite easy to acknowledge. The model are the classes that represent your domain cases, your domain objects, what it's about your app. The view, obviously, is also easy to check. It's the UI that represents the operations and the data that your domain represents. But the view model is that glue that join those two together. So sometimes it's hard to decide which code is UI code and which code is domain code, because sometimes that concept overlaps. So then arises the problem. In this case, I believe that the code used to calculate the exchange amount, it should be domain code, because this application is about that. So if we look at our models, we have, for example, a class called publish exchange rate, which represents obviously this exchange rate that have a validity, for example, the time span which this exchange rate is valid, the currency, etc. But you can see it's only a data store model. It's what we call an anemic model, because it doesn't have any behavior in it. It's just data. But we can fix this. We can move this code that we have here to the model, and the model can receive in a method, let's say, we want to get the exchange amount for this and this kind of operation, give me that. For that we have a branch, so you don't have to look at me typing all that code.
That's the best way to do demos.
Yeah. Let's make the magic happen. And yeah, let's look at our model again. Now this model have some behavior, some operation. It's looking much better. We have some methods that allow us to calculate the receiving amount, calculate the sending amount, and even later we check this one that create an exchange request for. And we have, for example, the number of decimal places that are used in the exchange operation. We can have that. And now that this logic is separated from the view model, is easily tested in my unit test. You can create a unit test for this class, and you can check that this logic is always right, that is taking the right property for the right operation, like buying, selling, etc. You can cover this case.
So can I review
Sure.
my understanding real quick? So
Sure.
essentially, what you're saying here is that you took your UI code and you had lots of business logic baked into your UI code, and you're like, no, don't do that. Let's take this business logic, pick it up, and move it over into our model classes, because that's more maintainable over there and easier to unit test. Is that what I'm hearing?
Yeah, exactly. You nailed it. So in this way, we can look on our view model again, and now it's even easier to understand what is happening. You can see that we have the exchange rate, and we tell it that please calculate the receiving amount for this exchange operation and this amount. It's quite clear. Before, we have a lot of operation of multiplication, divisions, and yeah, that's horrible. Now it's easier to maintain, and a new developer can look at this view model and say, okay, that's how it works. Okay, good. They don't have to, have to deal with the logic that make that operation. And if you have to make this same operation in another place, that logic doesn't have to be copy and pasted there in the view model. You just need to call the model, which is the right way to do it, really. So yeah, we are right there. So okay, then we have the button that says start the operation, that for domain terms create an exchange request, because we're trying to make this exchange with these parameters that we already set. And before, we have some code that create the object join, for example, the exchange rate that we already have, that we have taken from the service, and we put the amount, we put the operation type, and create all the properties. In this case, to avoid this plumber code, we can also move that in a type of factory method to the domain object and says, okay, this exchange rate, we want to create based on this exchange rate a new exchange request for. So we're using the domain and glue this code together to avoid treating the domain just like data store objects, like DTOs, and more like the business core logic that support your business, or in this case, this simple application. So yeah, that's a way to move some logic and reduce the cluttering in your view model. Another common problem, and let me switch back to our starting point, that you find when deal with view models on line of business applications is, as I mentioned before, that the line of business applications tend to have a lot of validation rules, a lot of complex interaction between controls. The line of business tend to be quite complex because of the amount of data and use cases and anomalies that they have to handle. So again, you end up with your view model big enough to be unmaintainable because you don't have an easy way to split all those line of code. It's not that your view model is wrong because it's huge. It's huge because your application is complex. So don't feel bad about it because it's large. Your problem is complex. The question is how we can split that complexity so we can maintain this application better. So another way to do it is implementing another pattern, which is quite popular in Android developers, which is called the use case pattern, which comes with the clean architecture pattern that is quite popular too in the Android ecosystem lately. So the problem with the view model being large is that we have kind of application logic, what we call application logic, and domain logic together, because sometimes we need to coordinate the operation in more than one domain object. For example, let's say that we have a credit score object that need to check the risk associated with that profile. Here in Peru, we have a law that doesn't allow to public exposed persons to trade so much money and things like that. For some operations, you end up coordinating more than one. So .NET developers tend to don't change their code structure unless they learn a new pattern. So let's put it a name to this fix, and that name is a use case. A use case is an object that let us take the code that you have on your view model that deals with the domain object and put it in a class so it becomes a unit that you can maintain and you can test separately. Because otherwise, your view model has to be tested more thoroughly, and they have a lot of dependencies and code paths and interactions between them. So let me show you how it works, so it probably be easier to understand that way. I have another branch for that, which is called use cases. Voila. So instead of having a giant view model, now we have this subject. Let me show the code. That is called use cases. Each medium to large operation inside your view model becomes a use case. It's similar to the concept of a command in MVVM. In the original MVVM specification, the command object has to be a unit of operation that encapsulates the logic and validity of that command. But that command usually have to have only one parameter. So if you want to encapsulate operations of a command, you have to have one unique object to pass.
No,
but in this,
what did you say this pattern was called again?
use cases.
use case pattern. Interesting. Okay.
Yeah, so instead of, for example, I don't know if you remember, because you have to be like paying a lot of attention to the code, but we have some code that initialize the exchange rate, get the defaults for that, change the properties here that we're using. Now we move that code to a use case, which is just a name for a class that executes some application plus business logic that don't belong to the view model. So let's take a look, for example, and get default exchange, or the get latest first. Get latest exchange rate, which is super simple. It just take the REST service and get the current exchange rate, which is what we expect. But now that is separated in a unique class, which is called a use case, we can modify it, augment it, and add more logic without need to touch the view model, without to clutter your view model with all that logic. For example, adding some retry policies with Poly, with our famous Poly library. We can use cache, for example, here, and add the logic here. So it's a way to decompose your code. Your code
I think this seems a lot more testable too, right? I mean,
yeah, exactly. That's the point. Now, your tests are easier to build. Before, don't get me wrong, before you can test your view models because you are injecting interfaces, your methods more or less could be tested. But now it's easier because you are testing a more atomic unit of code that only depends, in this case, for example, from one service. And you have to mock that service and only that one. Before, to test the same code path or code block, you have to mock all the dependencies that your Exchange view model needs, which are more. Now it's easier, you can modify this without touching, and if you need to get the same exchange rate in other part of your application, for example, I don't know, in your profile, and when you are setting up your profile, little at the bottom there is a showcasing the current exchange rate to stimulate the exchanges. You can do it and you can reuse this use case. The same happens, and it is more interesting, the next one, which is the get default exchange use case. Most of the information that is shown in the UI are properties that are set or defined in your view model. And this get default exchange use case need to somehow set those values. For example, the default amount that you are about to exchange. And how to do that without coupling your view model to the use case in this case, or the use case to the view model, because we don't like coupling. So how we can do that? Well, a way to do it is introducing the concept of context. This is a more interesting way to pass a context. In this case, this context could be in a test environment, for example, a mockup or a dummy object. But in the real code, it will be the view model. But we are not like tied to a specific view model class. We define only the properties that we need to have access to set those values in. And that's it. Let me...
Do your view models then implement that interface?
And our view model implement that interface, exactly. You're nailed it. So in that way, we can even move this kind of logic that have to deal with the properties to another class that is easier to maintain, easier to modify. Don't get confused, because these use cases already have this code that is moved to the model. It is previously to that implementation. Each branch is focusing only in one specific pattern, but we have another branch where all the patterns are implemented together, so don't worry about it. But yeah, that's the idea, that you have a unit of execution maintainability expressed as a use case. And that's important because, yeah, .NET developers want to have a name. It could be done with another definition. But yeah, have a name allow us to make that practice more approachable to people. So yeah, we use the use case pattern to encapsulate some application operations where we have domain logic with application logic. In that way, we use make our view models much more approachable. Now I can understand what is going on. When the amount you pay change, we calculate the change amount. When the amount you receive change, we calculate the amount you pay. It's easier, more expressive, make your code more expressive, more easy to maintain. And yeah, we can set properties if we define a context, for example, and make our view model implement that context, which make that, more approachable. It's important to highlight the context usage here, because another important hint, recommendation, or pieces of advice that I give you is don't allow your use cases to do more than it's supposed to do. So that's where the context play an important role. We can pass, for example, a change view model as a type, and you have access to everything. If you rename a property, it automatically pick up and everything. But your use case can modify properties that it doesn't supposed to modify, and that's a problem too. Some problems and bugs arise just for that reason, because some code is modifying something that is not supposed to modify. So like limiting the way that the code can interact between parties, it's important too. So that's why we define a context with only the pieces that you need to have access to. In this case, for example, the exchange rate, it's unable to be modified. You don't have permission to null this field, for example, change it, or something like that. So it only exposes a get. Even this domain object doesn't spawn setters for the properties. It's kind of immutable. We can be using records for this, but yeah, for clarify for other people, it's just properties with gets and not sets. So that's an important point that I have to make, that you need to allow your use cases or your code in general to only modify what is supposed to be modified. So yeah, that's another pattern that could be useful for you.
So there have been some comments while you were talking, Jesus. A lot of people just chimed in and said that this is a really neat pattern, and I kind of dig it. I've never actually seen the use case pattern before, so this is something I'm going to start playing with, I think.
Yeah, it's kind of neat. Yeah, I try to bring patterns from other languages and developers that can be easily ported to .NET if it's make a good point like this. This is much more popular in Android apps with.
I'm sorry, I didn't mean to cut you off. Do you have a GitHub? Do you have a GitHub somewhere that folks can look at?
Yeah, for sure. Do you want me to share right now? We can share at the end.
Send that to us in the private chat, and we'll pop it up on a link here on the screen.
Sure. Let me see. Okay.
And one
Perfect,
thing
we are.
I'm curious, because I never developed Xamarin or Maui, and so why do you think the MVVM pattern is the one that I've seen it mostly being recommended?
Oh yeah, but it's because first Microsoft introduced it and recommended to use it, and second, it's not the only one, but it's the most popular because when Microsoft recommended, it's like the default option. If you start learning to develop Xamarin applications or UWP applications, the immediate pattern that is recommended to you is learn MVVM, and it's quite good, I must say. But there are other patterns that fit in other use cases, and that's the main problem with this talk. It's quite specific and opinionated because it depends on the context and your problem and your kind of applications. I cannot tell you that you use these tips or patterns that I'm using. It depends. Sadly, it depends, as always, the answer. But yeah, I think that we can showcase some ways to do it, and you can pick the better fit for your problem. But yeah, it's quite kinda nice pattern, the MVVM pattern. That could be that I spend a lot of time working with that pattern, and I kinda like it. But yeah, there are other patterns there.
Funny you should mention that. Our friend Jose has popped in with a question. Wants to know if you could talk a little bit about the pros and cons about MVM and MVU. I don't know MVU and MVUX. Do you know what those mean, Jesus?
Yeah, for sure. And that's the thing. Now with MAUI, the paradigm change and shift away. Before, in Xamarin Forms, it was kind of hard to implement other patterns because it was focused and centered around the MVVM pattern, because XAML was the first language for the UI, and mostly the only one. But now with .NET MAUI, you can construct your UI with code similar to the way the React JS application do. So we can implement other patterns. Redux, Flux, and MVU, for example, can be doing there, because when you can construct the UI from the code, you enter in a kind of code loop, and you change from view model, because you don't have a state, a permanent state that is bind to your view. You have a execution loop, and you modify your code to express what this value comes from, not what is the value is that is in MVVM. In MVVM, I define a property with the value and bind that property to the UI. But in MVU, we have a code loop. I create the UI, and I said this entry display a value that came from here. I don't say it exactly the value, but from where you can get that one. And each pattern has its own pros and cons. I think that the main advantage with the MVVM pattern is that allow us to build complex UI behaviors in the UI thanks to the binding system. The binding system is the key thing there, because you can, for example, and I always use this example in my demos when I try to teach XAML. You can put a slider, and you can put a rectangle, and you can bind both properties from both controls to the same property in your view model, and then modify one and the other change immediately. So those bindings are the main reason that the MVVM pattern is quite popular. You can do a lot of interesting things there. But then, when you don't have a binding for the property you want, it's like things start to getting harder and harder. And I have a pattern for that case, but we are going to check it out later. But yeah, the MVU is having some traction right now, but I'm not that familiar with that, so I cannot speak for that one. Okay, any other question?
There was a question a while ago. Just somebody commented, do you play that Les Paul behind you?
Yeah, I try to play it more often, but yeah, lastly I haven't played in a while. I put it there in the wall to remind me that I need to, not let it hanging all the time. But yeah, I try.
I wanted to ask you a question.
They were asking you to play it.
Go ahead, Dave.
Okay.
Go ahead, David.
So I was curious, you talked about the view and the view model, and I recall you briefly talking about DTOs. Is that what would be like the models then that come from some sort of just peripheral data source?
Yeah, that's a good question. And again, it depends on the app, but most of the time, the model came from the way that the REST API exposes the data. So sometimes it's not recommended to have the same class being the DTO and the domain model, but sometimes when the teams work together and define a very well defined interface to communicate, you can use it. In this case, I'm reusing that. My DTO that communicates with the REST API is in fact my domain model. It doesn't have any problem, even if you have like private setters, because the serialization code can handle very well. So yeah, you can do it. In this kinds of application, it's kind of common. It's not like super recommended, but yeah, it depends on the case. If you have an API that is completely different from your point of view of the domain or your business logic in your app, it's like a third party or something, yeah, you will probably have to apply another pattern, which is the anti-corruption layer, and have a domain model. It's a projection, encapsulate or translate that representation from those people to our own representation. So yeah, but most of the time are the same. The DTOs becomes your domain model here. But yeah, it depends on other factors as well. If you have all your solution in one Visual Studio solution and you share the domain layer with the REST API, for example, it becomes different but the same. Yeah, it depends. But short answer, yes. Your DTOs usually are your your domain objects.
And Jose again, he was asking which MVVM framework could you recommend us to use?
Oh, that's a that's a good question. I have to say disclaimer that this is completely opinionated, and other MVVM frameworks are good as well. But I have a kind of love to the Prism framework, as a lot of people have. So yeah, that's the framework that I like. The Prism, and it came from the WPF ages. So yeah, it has been with us for a long time. So that's probably another reason for my likelihood to use it. So yeah, I recommend the Prism, but as I said, it's completely biased.
We got another question from Jason. So MVU is model view update. What does the X stand for? Do you know?
Yeah, that's a good question. I don't really know, but I will check it out later for sure. As I said, I'm not so used to that pattern, but it's new in .NET MAUI, so I'm ready to try it and see how it goes. But yeah, that's the neat thing about .NET MAUI. It opened the doors to other patterns now, so it's up to you to choose which one is a best fit for you. I tried to showcase in this talk the MVVM because it's more broadly adopted in the .NET ecosystem. So that's the only reason.
I wonder if it doesn't stand for XAML. Maybe.
Yeah, I don't think so, but it could be. I don't know really.
What about extreme?
or 10x, like
yeah,
you're
that's
a
what I was
developer. Just add an X to anything and it makes it better, right?
Okay, let me switch to another.
Oh, so we actually have an MVU expert in our audience? No, I don't know what our audience members are talking about now, but they mentioned that Jason Perry presented a...
Ooh.
I don't know. Or he might be joking.
No, he
That's- I
he
don't know.
was
Maybe they're
replying.
just tagging
He's
him,
replying
like, as
to
a
Jason.
reply.
Yeah, because
Just saying.
Jason was the
Oh,
one
oh.
who asked the question, so he.
Gotcha,
So
gotcha,
Josiah
gotcha.
is just saying that it was presented
Sorry.
at UnoConf. So
We're gonna put Jason on the spot
I'm
and
out of
call
coffee.
him
we
into
need
the
to
show
go
right now.
look for the talk about MVUX. Yeah, Josiah is all like he probably knows all better than all of us because he's in all the streaming. So I know he knows a lot about .NET.
Okay. Let me mention very briefly another case, more for beginner developers, but I think that is worth mentioning. When you start building Xamarin or UWP applications, you don't have the concept of DI container or the measure of control or dependency injection. You don't have it right off the bat. It's not like ASP.NET, where you have services and you can configure it. Here, you have to do it by yourself. So sometimes people don't use it. I thought that most people use it, but I think that is worth mentioning. And it's allowed me to clarify a concept between what's the difference between DI and inversion of control, which are terms that are similar but are used interchangeably, but they're not the same. When you use DI, you inject dependencies and usually have a class that is dedicated to resolve the dependency tree, create the objects that you need. In this case, we're doing that manually. We have still our dependencies. As you can see, we expect to receive exchange rate service, for example, a navigation service. But we are not automatically write up everything. We are manually constructing. And if you add new dependencies, you have to modify your code and so on. So you can resolve that introducing the dependency injection. Let me switch to this one. But
I just
the other thing.
I just wanted to say something real quick. That little feature that you're using within Visual Studio to quickly change the branch, I didn't know that
it's the preview version of 2022.
I didn't know that existed, so thank you for that, 'cause I manually do it from the
Yes,
command
quite
line.
neat. Yeah, I have my fork Git client in the other screen ready to switch in case anything happens. But yeah. So yeah, when you use DI, you have one class to do that construction for you. But the inversion of control happens when you change the construction flow. You can, for example, let me show you here. Here I'm constructing the pages, for example, manually, obviously. There is no automatic DI built there. But I have the inversion of control in place because my pages doesn't know about the view models. They don't know how to wire which is the right for each one. Even where I'm manually building up and kind of lacking DI here, I invert the control of the construction. So I have two different concepts. The way in the objects are constructed or created and the order in which the dependencies are weighed up. And in this case, I'm doing manually. But yeah, a good recommendation is implement the DI inversion of control, because in that way you can speed up your code, separating classes, build other services, and it will be much more easy to put it all together back. Because if you don't implement DI, you have to deal with that, which dependencies need to pass to which page, to which view model, and so on. So that's just a heads up for you folks that are watching us, that implement DI. Even in .NET MAUI, that is super preview right now, we have some dependency injection containers. Let me see. I think that I'm using dry IOC. Here is my DI container configure. So we can implement it even in MAUI. There is some Prism preview super alpha version at this point that you can try it, but you have to expect that some changes will be in the future.
Yeah, and I think early in the streaming, people were asking like that they cannot even run MAUI at this point, and I would say like go to either the repo or file a bug through the Visual Studio if you're getting issues while trying to run MAUI, because the team is looking for that feedback, right? And what is blocking.
Yeah, that's right. Point. You can check also, I don't know if I have opened that one, but in the GitHub repo there is a status page where you can check the status of the MAUI evolution and what is implemented and what not. You can probably run an app and say, oh wait, why it's not showing this collection view, for example, in my Android app? It's because it's not implemented yet. It's not because your installation is wrong or you are doing something right. Check the status also to see in what point we are right now with MAUI. But yeah, there is a lot of progress that has been made. Heads up to the team, congrats to the team that is working with that. Yeah, it's kind of exciting. I'm looking forward to see the final release of .NET MAUI. In the meantime, I'm working with it in this stage to see what are the rough points that we need to deal with. For example, to implement some unit tests, I have to move the core logic to .NET 6 library to make that easier, because this project used different monikers about the framework, and that's kind of tricky to make your tests work. So, for example, that's a thing, but it's reported, and the team is looking to make that experience a lot more easier. But yeah, are rough edges that we need to deal with.
Yeah, they're really working super hard to release this.
Yeah, exactly. Let me show final two patterns, tips, how you want to call it, about this code split up. Let me see if I can run this application real quick. Another way to...
real quick, Jesus, while you're doing that, we did have a question about how would you do debugging of XAML bindings?
Ooh, that's a great question. It depends of, I depend most of that tooling. I base most of the tooling because you get some warnings when you have bindings that are bind to incorrect type of properties or properties that doesn't exist. But I rely mostly on them. That part is one of the reasons that other patterns exist, because they can construct, if you construct your UI from code, you can test it quite well. But in this case, this binding is a loose couple way to connect your view model to your view. So given that it's a loose way to do it, you cannot test it per se with a unit test, for example, but you can do an integration test that is quite popular for that kind of things. UI, a code UI test, that will be the answer for that. But in the, let's say, developer loop, you will probably check it out, the output and the warnings that you get when you are not binding to the correct property. That's quite important.
Awesome, thank you.
Okay, another way to split up your logic is that some screens are complex because those screens are composed for more than one feature. For example, you have a main feature there, and you have, let's say, a showcase of the latest performance of your exchanger, the amount you save, or side panels and things like that are part of the same UI. Yeah, putting all together makes your view model obviously bigger. So a way to fix that issue will be split up your view model and make a view model for your main feature and another view model for your second feature, and say, oh, well, that's kind of simple. So what's the thing there? Yeah, but sometimes those features are not related, but interact between them. So it's like they are not completely belong together, but have some relationship between them. And that's the problem. So a way to separate that, in this application, I don't have a use case exactly for that, but I have a kind of similar. We have several tabs here. So when you register an exchange operation and you go to operation, you expect that the operation is already there. You don't want to refresh or wait because you already registered. So you need to communicate between those two. So a way that you can use to communicate two separate parts of your application or UI is using what we call an event aggregator, which is kind of like a boost probably in the backend terms. That is just man in the middle. You talk to that and he talks to the other parts on your application. For example, let's check the register here. The register. When you register your new exchange operation and everything is fine, you can throw or raise an event here that says we have just registered a new operation. And then, with this little class in the middle, and then your other parts of the UI, for example, the operations view model, can be listening to that event and react to it. So you can communicate to paths. It happens, for example, when you have a card icon in one part of the UI and you're adding products, you don't want to be like bind to that one because that card could be other behavior or something, and you don't want to be part of another view model. Maybe that part exists in the main page, in the container, so the view model doesn't have access to it. To solve this issue, you create another one for that specific place, but use an event aggregator to communicate between them. You can throw events, and the other parts can be listening to it. So it doesn't have to know exactly where that data come from and things like that. It decouples parts of the UI that has to interact between them, but doesn't belong together. That's the main thing. And yeah, again, it depends on the use case, because that's the thing that you have to figure out, if it's belong together or not. That's the hard part. But yeah, I want to share the way to communicate it. Is you can use an event aggregator, and that patterns have been stolen from the Prince framework, because the Prince framework exposes an event aggregator too. That's a recommended pattern when you need to communicate to separate UIs that depends on each other but don't belong together. So I hope that could help in some cases. In this one, you start your operation with sell. We load your bank accounts for each specific currency. Everything's well. You go next. And we confirm and get the information. Okay, we finish. We can go to operations, and the operation is right there. So yeah, it's depends on each other, but doesn't belong together by any means. So that's the summary of that pattern.
I've got a real quick question, and this is kind
Sure.
of like a super technical question, but
Ooh.
so in the UI, when the user is interacting with the different navigation controls there at the bottom, say for example, if they start an operation and then quickly navigate away, is that operation canceled? Or
no, all the in this specific demo, because I cannot speak for all the apps, but in this specific demo, all the tabs exist at the same time, and when you navigate away, it is still having the tab there, so it doesn't. Yeah,
I'm used to like web development, where if we show a different page, you know, it's everything's gone, stateless, right? Like so, okay.
Yeah, client UI is kind of different. And the last trick in my sleeve is what we call the implementation of a controller or an interactor. And this one was stolen from iOS development, especially when you use Swift and use the MVC or MVVM pattern. They usually tend to add a new component to the pattern. It's not MVVM, MVVMC, for example, because they include a new actor in the mix, which is the controller. In this case, let me showcase another app. This is a sample app that I did a long time ago, but showcase a control that I built. I draw some points on the screen and made a progress status bar, but doesn't have a bindable property for the status in which you are. So that's a problem. And sometimes it happens with other applications and other general third-party controls, where you don't have the access to modify the control per se, but you need it because it looks the way exactly the way you need it. You need to use it, but sometimes it doesn't have the properties for what you want. This is a control that is kind of little, right on the top. Doesn't have bindable properties for the status and which one you are. So sometimes you end up with a lot of Plumber code because you have to mix like code behind code, because it's part of the view, with the view model, because the view model knows the status. The state belongs that place. So how do you solve that problem? Well, as in all of the other cases, with the introduction of another component in place. You can define, in this case, I call controller. You can call a presenter. Interactor is another way that people call it. That handles the interaction with that control that doesn't have bindable properties. And the view model only have to deal with this one that has some property more approachable for it. So you can abstract that code away from your view model view/view model. You can have much easier to work with code. And the controller is quite simple. Let me see. You can implement it, yeah, this way. You can see I have to set the number of statuses. It will be better if we have like an items property that I put it and show, oh, no, it has a number of statuses, which is super old. And the correct index in which you are, which is obviously, again, super hard to work with. I have the current status. I don't have the correct index of that status in your UI. That's not a, let's say, a view model concern. They don't know exactly how you are representing that concept in your UI. So that code doesn't belong there. Given that we don't have bindable properties, we cannot expose or use a converter or something because we cannot have or use bindings. So that's the scenario. You cannot use bindings, which usually solve that problem, but you have a control that you need to use for some strange reason. Or some controls expose some bindable properties for some things, but not for others, for example. So that's another case also, when you need to implement a kind of abstraction for it. And in this case, I call it status controller, press status controller, and is mediated here. Let's see that the page doesn't have any reference to that controller. The page doesn't know it. It only exposes UI code. But here comes the inversion of control. Instead of the page know about the view model and the controller, there is a top level entity, which is called the application, that knows about it and, create and put all the pieces together. This is inversion of control. You can instantiate this one in the page and then relate it and set your binding context where your view model resides. But yeah, the page will be responsible for it, and we don't want that. We can change that in the future. We can use alternative views for different OS or form factors, for example. We don't want that relationship. So we use a top level entity, in this case the application, and build all of these dependencies together. And in that way we can, let's see if it's move again the statuses from the view model without any problem. That kind of indirection thanks. That kind of indirection it's made, and this pattern is stolen from Swift. In Swift you usually do that because some controls you don't have a way to bind a value from your view model directly. You need a lot of time to put code to directly manipulate the UI. So to avoid some code smells and cluttering your view models, they use the same pattern. They create a controller and use the controller to interact with the UI. So you can split it up. Yeah, that will be the summary. Let me share this little outline. Yeah, I published the outline. It's a work in progress, people, in my blog, so people can check it out.
Can you copy and paste that URL into the private chat?
Sure. Sure.
Yeah, and that was awesome. I learned a lot about patterns today. So thank you so much, Jesus. I haven't tried Maui. I tried just a very basic template, but nothing beyond that. But then, yeah, it was awesome. I learned a lot. So thank you so much for joining us today. And I hope everyone enjoyed. And tune in next. Do we have a show next week? I think we do, right?
Well, we do. We have
Stephen Malm.
Malme? I don't know how to pronounce that. I apologize, Stephen.
Yeah, and it's immersive application performance management. Enter the world of your app. So stay tuned and see you all next week. Thank you.
Bye.